Our next speaker is Juliette Sulmona from Apexagri. She's an agri-food engineer and consultant specializing in sustainable development. And she will talk about the responsible and sustainable microalgae value chain.
So thank you very much for being here, and thank you for the quick introduction. So I will be fast and quick. I have like 5 different projects to present in 20 minutes, and then I will let the floor to my 2 colleagues, Marinella and Maresa, which are here. So the first thing that we studied is we tried to map the European value chain and made a graphical representation. So we published this figure in 2020. So I think that this that repetition is not. It's a little bit outdated, but we have the different stakeholders here, like the different steps, which are still the same now. And we also identifying different key points which are really important to face for the European value chain. The first one is that all the actors of this value chain are a little bit fragile and have like fragile financial structures and are barely profitable. We also observe that the market is far from the nominal level of trade despite the sustained growth. There is a constant technology renewal. We see it like there is a lot of innovation, a lot of technical improvement, also different type of new strains. We don't see any strong lobbies, committee or grouping of actors who can bring a like shared vision of microalgae market, and we also don't see any common or equivalent basis on calculation of the product cost. So Marinella will talk about this, but we try to create a tool to foster this calculation. Then Lisa, here she is, and ZSI work on the social perspective on the development of responsible microalgae value chain. So they organized and facilitated 2 multi-stakeholders workshops and co-created 4 scenarios of sustainable, just and responsible microalgae production and value chain. And these 2 workshops led to a publication of an article. And this article details different key findings. The first one, Lisa can complete if I... Okay, so the first one is it's a key point to identify all the different stakeholders in order to strengthen and to enforce the dialogue and the collaboration between the different stakeholders among the value chain. We also agreed that microalgae food and feed products is niche sectors, and it's really important to get political support, to get the necessary funding, and to build the new requirement for the sector. It's really also important for all the company to be totally rooted in the food sector. Financial and technical uncertainties have to be minimized by the support of the policymakers and the funding agency. It's also important to have the collaboration with large and well-established industries. And finally, at the current stage, the agency of consumer and civil societies is underestimated in the microalgae-based value chain, food value chain, and we know that the demand is key to render the microalgae food product relevant and sustainable. This morning we talked a lot of the valorization of the microalgae side product. So Simon here worked on this aspect. So due to delay, we were forced to work on spirigase, which is let's say the waste of the spirulina extraction. Okay. So spiragrace show interesting amino acid profile, good techno-functional properties, also a good amount content of protein in the biomass residue, around 60 and 70% of protein. But it also shows it's difficult to valorize for food application due to high microbial contamination and difficulties in drying. So they wanted to try something to reduce the microbial load. So they try to compare two different techniques, so the HPP, the high pressure pasteurization, and to compare it to the normal one. And also they work with Nectin to dry it like a solar drying. So the result of this comparison between high pressure pasteurization and traditional wine, so it showed that both of techniques are sufficient to reduce the microbial load and to lead to safe food products. But HPP showed also more advantages because it reduced the effect on protein denaturation, color and particle aggregation, and also maintain or, in certain cases, increase some techno-functional properties on the contrary of heat pasteurization. Yes. So what we can conclude on this part is that spiragrace is really interesting for application for food and feed, as it contains high content of protein and also high content of essential amino acids. But due to microbial issues, it's important to find a way to reduce the microbial load. But high pressure pasteurization looks like a valuable option for the decontamination, and we also see that the HPP increased functionality of the spiragrace compared to the normal one. And in case we try to work with spiragrace, is really cost effective because we estimate that spiragrace is half the price of the fresh spirulina. So really interesting for our next food and feed try. Now I think Maresa or Marinella will...
Yes, we have Marinella as our next speaker. She is working at AXIA Innovation, and she is specialized in bio-based advancement, and she evaluates impact studies as well as data to help us create tools that assess sustainability and circularity.
Thank you for the introduction, Mari. Hello also from my side. I will start saying that something that we already know, something that we already all of us experienced. Today we are living in an economy that tries different alternatives, okay? Here we are gathered all together to search for different alternatives, in food and feed. So the way that we have decided to feed ourselves and our animals has changed. And we are doing this because we are searching for different ways towards a more sustainable and circular future. When I talk about alternatives, in my mind comes the word options. So I have different options. I have different options to select different raw materials, different resources, different technologies, and different final applications, different final products. If you consider that we have a lot of options, at the end of the day, at some point, we will have to conclude and decide for one of these or two of these, or three of these options. So we need something to guide our decisions. So what are companies, what are companies struggling to do within this sector and within all these sectors that are struggling with this new alternative sources of energy or biomass, is that they are struggling to find ways to assess their processes, to assess their value chain. So they pay money, they need some consultants, they need some softwares to achieve that. They pay money by consuming time, because I need to take one number from here, one number for another report. Let's see what is in the literature. So this is a very time-consuming and a very cost procedure. So we thought that what if we could solve this problem? What if we could solve this challenge? What if we could gather all of this into a single decision support tool and provide a holistic environment where the user shouldn't be an optimization expert or an LCA expert. He can just run a study selecting the value chain that he wanted to study. So we created a tool that considers all this together, considers energy, consider cost, consider LCA data that we thank very much ESU-services that Maresa will explain you the environmental aspects after my presentation. So we started by defining the value chain. We developed a methodology based on process engineering because we are chemical engineers in our team. Then we collected the data, and then we created a database formulation that will be able to include all this material and the scaling up of this material. Finally, we developed an optimization code to optimize, to screen all these value chains. And finally, we developed a user-friendly interface in order to be able to provide this tool to the audience. And we gave it a name. We named it AlgaVantage, from algae and advantage. So here it is, our logo that we created, and I will explain why we created also this logo. Optimize, innovate, AlgaVantage is our slogan. And I will show you a brief presentation of the user interface. In the first tab, you will be able to review all the processes that are included in the analysis that we have. The second part, the user can develop his or her study based on step-by-step development of the value chain, and step-by-step he will be able to see the energy consumption, the LCA, the costing, etc. All the things that are major, but as I told you, this is customized, so we can include more aspects and more factors if somebody needs to. And the final tab is related to the optimization code. You are selecting the path that you want, you are selecting the final product that you want, you are selecting maybe otherwise the raw material that you have, and you are running an optimization problem without knowing anything about optimization. So approximately, this is how it looks like. This is the second tab when you are working step by step. You are selecting the raw material, the protein, that you want to produce. Here you're selecting the different categories based on cultivation or disruption or drying, etc. And here you get the results. This is confidential, this is why it's not shown here. The results, you cannot see it here, but this is the greenhouse emission, energy consumption, energy cost, material cost, labor cost, etc. And this is the total route. And finally, the last point. I told you one of the problems that you can solve is to select whether you want to go to feed or food, or maybe you can select both of them. Then you select which one, then you determine the quantity, you play with some factors that are critical for food, for example, the color, the taste, and then you get some results, some ranking results about the optimization of this value chain. I will be in the poster session also tomorrow, so you can also review the tool there, approximately, not all the tabs, but we can show something. And finally, we are very happy because with AlgaVantage, we were invited from the European Union for the Innovation Radar Prize. So we are waiting for the whole procedure to start. It will be at some point a public voting, so we will engage you all if you like these results to vote for us. And finally, this is our team from AXIA Innovation that we are working on the back, the data collection, the data formulation, the optimization codes. This is our team. And of course, RDC, our partner that are developing the user interface, which we'll thank all very much. And of course, as I told you, we also thank the LCA partner that provided us the data for the LCA analysis. That's all from my side. Thank you very much.
The next speaker, we have Maresa Bussa. She has a background in energy and environmental engineering, and she will tell us today about life cycle assessments of microalgae.
Yeah, thanks for the introduction. And yeah, I will give you a quick deep dive in part of the results that we generated in ProFuture. Just as an introduction, we had two parts mainly. The first one was comparing all the different technologies that were presented to you in the morning in terms of costs and environmental impacts, to see which ones are the best: cultivation, drying, disruption, and we didn't do the protein extraction part. That was the first step, and afterwards the second step was to look at the food and feed products and compare them also to conventional alternatives and to see how the microalgae-based products perform in comparison. Just a very short methodology slide in case that there are some LCA people here in the group. So what we used as a functional unit, so as a basis for the comparison, it was always a provision of 1 kilogram protein, because that's what the whole project is about. And we had the different pathways which we compared. And for the comparison, we used the environmental footprint impact assessment method, which aggregates a lot of different environmental indicators and allows to aggregate them in one single score, which makes the comparison a bit easier. As background databases, we used our own ESU database and ESU World Food Database. And on the right side, you can see the systems that we analyzed. So in the first step, we just had a look at the production of single-cell proteins or protein isolate. And then in the second step, we analyzed the whole product system, also including the processing ending up in a food or feed product. And we excluded the disruption and protein extraction because the yields were too low. So we focused on the single-cell protein. And I have just one example to show today because we don't have too much time. So I picked the vegan sausage. And here we can see, first of all, the comparison of the nutritional values. I used two benchmark products. The first one is a pork sausage. So that would be the animal-based protein source. And also as a plant-based comparison, I used tofu. And what we can see is that we have a algae content of around 3%. The protein content of the vegan sausage is lower compared to the pork sausage and the tofu product. The fiber content is a little bit higher, and the calories are somewhere in the middle, a bit higher compared to tofu, but below the pork sausage. And based on the cost estimation that we did, we assume that it's around plus 30 cents due to the inclusion of microalgae in the product. In the first step, we analyzed the contribution of the different ingredients, and what we can see here for the three main ingredients in terms of environmental impacts, we can see that microalgae, we saw the quantity below 3%, but it contributes with around 23% to the climate change impact, and we also saw that rape oil and pea protein isolate contributed over proportionally compared to their quantity in the recipe. And now the benchmark for the provision of 1 kilogram protein, including a lot of different environmental indicators into one single score. What we can see is that the vegan sausage and the pork sausage are pretty much in the same order of magnitude. It's around 8% higher, the environmental impacts of the vegan sausage. But it's important to keep in mind that in general we have an uncertainty of 10 to 20% in LCA, so this difference for us is too small to say that the one product is better or worse than the other one. And it's also important to highlight that it's kind of an unfair comparison that we are doing here. The microalgae is still in development, the whole industrial sector, as we also heard earlier today, and we are comparing it to very mature sectors. So that also explains at least part of the difference that we see here. And to conclude, what we saw is that microalgae can compete with animal proteins, but not yet with plant-based proteins. And what I didn't show you, but what I learned in the other calculations that I did, is that the cultivation stage is by far the most important part of the value chain in terms of impacts and costs, and that's mainly due to electricity consumption, and that also gives a hint what to focus on for downstream processes. It's quite important that you have high yields in terms of protein extraction, but also, for example, for drying, if you lose a lot of biomass, which was expensive in terms of environmental impacts and costs in the production, then it's a drawback if you lose too much in the downstream processes. Yeah, thanks, and maybe you two want to join in terms of questions.
Are there any questions?
Thank you for your presentation. Sorry, I'm Olivier Lépine from AlgoSource. When we speak about LCA, one of the key issues for microalgae is the land issue, meaning that we have discussed this morning that soya is associated with deforestation, whereas microalgae can be cultivated on non-arable land. Well, it's not always the case, but it can be. And usually the models, the LCA models, do not take into account this positive aspect of microalgae. So I wonder, how have you treated this parameter in your analysis?
Well, what's taken into account is direct deforestation. So if it's really deforestation to afterwards plant soy in that area, what's not taken into account in LCA is indirect deforestation. So if soy cultivation in Europe is increased, which pushes cultivation of other plants to Brazil, for example, that would be indirect impacts, which are usually not considered.
Okay, well, I just want to insist because I think this is key. So, if I understand correctly, there is an indirect impact for soya, and there is also for microalgae cultivation, because the model as a basis does not take into account any positive issue. So, if I understand correctly, in fact, the fact that we cultivate on non-arable land is not taking into account as a positive factor.
It is, let's say, taken into account as a less negative factor, because mainly we talk in LCA about negative impact, so that's definitely an advantage of microalgae, that you don't need arable land for cultivation, but yeah, the electricity consumption is the main reason for microalgae still having a higher carbon footprint compared to soy.
And one last point on this. Electricity will be the European mix energy.
Yes, yes.
Okay, the current energy mix. So Portugal or, well, in Necton, they did this trial with PV, so decarbonized electricity. This was not taken into account in the results that you showed us.
In the results that we saw here, I think it was with chlorella, if I'm not mistaken, for the sausage, and that was not the one tested with PV.
Okay, so we would have had different results if you had taken into account the optimization that were done here in the project.
Yeah.
Okay, so maybe this is something we could do before the end of a project, to actually have this scenario where we integrate optimization to have a fair comparison between where we want to go and where we are now.
Yeah, that would definitely improve the results if continuously renewable energies are used for cultivation of microalgae.
Hi, I have some follow-up question, not on the electricity or on this framework, but in this work you consider the chlorella, so it was fermented, right?
Yes.
Do you have comparisons using autotrophic biomass and heterotrophic biomass? Is the impact of the production mode, or is not included in your other analysis that you didn't show today, of course?
I've collected the data and I did the calculation of each individually, but not yet the comparison in detail. But I think that the heterotrophic performed better compared to photoautotrophic, but that's a guesstimation at the moment.
Thank you.
Yes. I've seen a hand somewhere. No? Okay. No. Okay.
Just have a question. Have you considered also the LCA of omega-3 or
No,
not?
we didn't.
Yeah, just focused on proteins.
Yes, exactly.
Okay, thank you.
Okay, one last question then.
This is a question for Apexagri on your modeling. No, sorry, for AXIA on your modeling, on your tool. Well, could you give us an example of what you mean by optimal value chain? For example, comparing two different value chains.
Okay, take into consideration that you are discussing for different species of algae to produce a particular product. For example, pasta. It can be made by, I don't know if I'm correct right now. It can be made by spirulina, by chlorella, or whatever else. You don't know which is the best way to sustainably achieve that, to achieve it in a less energy consumption, in a most lower cost that you can do this. So you can run this model to say that my target is to produce, for example, 1 ton per year of pasta based on algae, which is the best possible way to do this, and you select the objections that you have, the objective that you have. I want to reduce my cost, I want to reduce my energy. And then this selection is taken by the optimization model, and then you get the optimal solution for your case. Or maybe you can say that what will happen if the raw material that I have is not enough? What is the next protein that protein source that I can use to produce this pasta, for example, to make my industry working during the year, because I have to make it feasible during the year.
Hello, my name is Paul Vos. I'm from Wageningen University and Research. I have a simple question also for the second speaker on this decision tool. So I'm involved in another EU project where we focus on a lot of different alternative protein sources. We also want to look at value chains and LCAs. I'm interested just to learn from the tool that you've developed. Can you explain how much is it open for people outside of this consortium or in the future?
I was expecting that question, and we discussed it also with some of the partners. For the time, it is just for the partners of the consortium, but we will discuss it internally to its availability after the project ends. But I just wanted to comment that this tool is customized. For example, if you want to add 5 different extra species, we can incorporate that, okay?